also giving, or you're also, I mean, if you're trying to do subtraction, then you're also pressing the minus symbol, then you're going for the second value. You don't have to write in any sort of codes, or you don't need to type in any sort of symbols to do a simple calculation using your calculator. But to make this is actually the calculator is actually designed like that. You don't need to do that. But inside your compiler, especially in this language, when you try to do some sort of calculation, when you try to make it act like a simple calculator, you need to make, or you need to provide something else inside your operation like this. So the literal value, when we try to tell the compiler this, you need to take this value as it is, and you need to do the calculation as it is and tell me the result in a decimal form. If you want to do that, then you need to write like f or like f, and so the editor automatically removes that red underline from my code. So inside your calculator, you wouldn't have to actually provide something like this f to tell the calculator that you need to take this value as it is and produce the result in decimal form. But inside your compiler, just think that you need to make it work like your usual calculator. So if you want to do that, you need to provide an f after this decimal value, and you also need to provide another f after the second decimal value. So this will tell the compiler to this will actually tell the compiler to refer this value as float and store them in 4 bytes of space. Now, as I already explained with the character data type and the string data type, the compiler will first look at your data type, which is float. Then it's also going to look at the values individually. So it first looks at the first value, which is 20.10. Then if it sees that there is f, it means that it's actually agreeing with the data type. Then after the minus symbol, it's also going to look at the second value, and when it actually encounters something like this f, it's also going to refer to this value as a float value that needs to be subtracted from the previous or the first value. So then it actually when this code goes to the compiler then reads them as float values. Then it removes the f from this operation, and then it does the processing, or it does the computation, or it does the calculation. Then it stores that value inside this variable. Now, because both of my values are agreeing with my data type, now my compiler won't throw the error for line 6 anymore. So let's recompile this. Okay, we didn't save that. Let's save this and let's recompile this. Now let me clear the screen. Let me go for the compilation part. Now you see that I have removed, or I have solved the first problem that included line 6. Now I need to solve the problem that includes line 8. So the solution is actually similar, but the symbol of f refers to float, which means that this value agrees with the data type. Now I need to make this these values correspond to its own data type of decimal. So to make this correspond to decimal data type, I need to type in something like m or m, like this. Now it's all right. So it's not throwing it's not actually showing me any errors right now. Now these values are by default referred, or they're actually by default considered to be a double value. Now I am converting that double value, or I'm actually telling the compiler, when I add such a symbol as M or F, I'm actually telling the compiler through such symbols that you need to refer to them, or you need to consider these values as decimals or as floats, not as double, because by default there will be these values are regarded as double values, or values that should have a corresponding data type of double. To override that default behavior of the compiler, or to remove that default behavior, of the compiler where it considers that these values are double, we need to remove that consideration from a double to decimal or float, and we do that using such symbols as F or M. So this M refers to decimal, and this M also refers to decimal data type. Now, because both of these values are now agreeing with the data type, that's why my editor is not showing me any sort of error right now. So we don't need the character variables right now, and we also don't need the string variable. Now let's comment them out and let's save this. Let's go back to the command prompt and let's clear the screen. Let's recompile this. Now it compiles successfully. So literal values or numeric literals actually helps us to understand, or actually helps us to make things clear, in the sense like those values had a default data type, like the default data type of double. If you look at this code, then you see that when I use monitor2 as a double variable, I didn't actually include any sort of special symbols to tell the compiler that this is double. So it tells me something, that these values are by default regarded as values which are double in nature, and they will be stored with 8 bytes of memory in space. But if I want to store them in larger memory, suppose that I want to change this calculation later on, and I want to store, I will need a larger space for my memory. Like I might need 16 bytes if I do a huge calculation that involves financial transactions. So if I need to have 16 bytes of memory space, it's better to do the calculation in decimal, or provide the data type as decimal, and you can use the literal symbols as M after your values. But if you want smaller spaces for your values or for your calculations, then you should go for float, because it requires, or it will give you 4 bytes of memory space. So if we run this program, we should actually see some sort of output, because I have included a write line method in here, and I have passed in the variables into format specifiers. So let's run this program. sequence2.exe, this will be the executable file, and we see the output. We see the output as calculated results. So your compiler now is actually working like your calculator. So you have a program which simply subtracts one from the other. Like if you remove